Turn the Grasshopper preview off now for the moment and go to Rhino. Switch to Rendered Display if you are not already. Select the baked mesh and Alt-drag the blue arrow of the gimbal to copy the mesh in the Z direction. Turn on the control points and reshape the mesh to its first distorted position. Repeat this step until you have 5 new meshes. These will be keyframe images that will be interpolated in the final animation. Also copy the original to the top of the stack so that the animation can be looped. You can use a pair of facing clipping planes to preview the sequence. Once the keyframes are ready, return to Grasshopper. Turn the preview mode back on to shaded, but select everything done so far. Right-click on a blank spot of the canvas and turn the components preview off. Add a new mesh param to the canvas and set multiple meshes, picking them in order from bottom to top. To create the interpolation, we want to trace the path each vertex takes from one layer to the next. In the same way that explode curve was used to extract the component vertices of the curve, deconstruct mesh outputs a mesh's component parts. Creating polylines from the vertex outputs gives the opposite effect, however, tracing one curve through every point in a mesh for every mesh rather than across the meshes. This is the impact of the tree structure again. This output is divided into 6 branches, one for each mesh input and each with 88 points. The desired output is 88 lists of 6 points each instead. More complex and direct editing of the tree data structure is possible, but for now there is a simple option called Flip Matrix that does exactly this. Now connecting the flipped output to the polyline component produces the right outcome. To actually follow along these curves, we'll use an Evaluate Curve component and a number slider from the Params tab. Evaluate Curve has a T input, and in the same way that the UV coordinates were like an XYZ grid embedded on a surface, T values are like a number line stretched over a curve. The slider and Evaluate component is a very common combination. When working in Grasshopper, modifying the slider, it's clear that 0 returns a point at the start of the polylines, and 1 reaches the first vertex point. This is a convenient pattern for polylines. Note that other types of curves will behave slightly differently. Double-click on the slider's name to adjust the max value of the range based on the number of meshes you have, and click OK. Now it just remains to rebuild the mesh from these points. Construct mesh is the operative component. Supply the Evaluate Curve point outputs as the vertex inputs. Flatten this, because all the points should be brought together to make just a single mesh. The F input, faces, tells the component which vertices are connected to which others. Since this information never changes in this example, this can be taken directly from the earlier deconstruct mesh component, which gave face data as output. There are 6 sets here, each of which is creating a copy of the mesh, which is redundant. Only one set is necessary. Tree branch can be used to select just one of the branches. The face data is the tree input, and to indicate which to select, you will type the address of one of these branches into a panel. For example, the first branch is curly brace, 0, semicolon, 0, curly brace. A shortcut for panels is to double-click the canvas and then type // in the search bar, followed by whatever text the panel should hold. This will replace the face data input, and then the constructed mesh can replace the Delaunay mesh in the custom map component. Sliding the slider will now produce a moving image. Disable any clipping planes, hide all the Rhino layers with geometry, and unpreview any unnecessary geometry in Grasshopper, and in the top view, you can see the final morphing image effect.